Hi, in today's question of the day, we will be discussing a question. Again, this is primarily based on the concept of projectile motion with a little bit of fundamental understanding. What I would say is a common sense. Now, if we look at the question, in this question, there is an object which is being thrown horizontally with a speed u, and this particular ball strikes a dome at a height r by 2 from the ground in such a way that it rebounds back to the same place. It means what? It means at the point of collision, means wherever this particle is colliding, and it is given that it is colliding at a distance r by 2 from the ground. So let's say here. So as far as retracing the same path is concerned, the thing is velocity component along x as well as along y both should reverse its direction after impact. So this is possible only when the particle is striking this particular dome perpendicularly. So if the particle is striking this particular dome perpendicularly, means during a strike, just before a strike, its velocity vector should be in such a direction such that this lies along the normal. So this is the velocity with which the particle is colliding, and the rebound velocity again should be such that their x and y component of velocity is just getting interchanged. Means with the red color, whatever I am drawing right now is velocity after collision, and with this blue color now which I am drawing, this is velocity before collision. Again I am repeating, velocity before collision and velocity after collision. This should be identical with same numerical value but in opposite direction, then only particle will retrace its path. So as I said, this is possible only when the velocity vector is along the line normal to the dome. It means it must pass through the center of the dome. At the same time, in this question it is written that the particle is striking at a height r by 2 from the ground. So if this is r by 2 and this is radius r, it means this particular angle must be 60 degree, because r cos 60 is r by 2. So this should be 60 degree. This is r by 2, means this particular height, that is from here to here, this particular height we will find out, let's say y, and this particular distance x, that is displacement along x. So this let's say this is x and this particular height is y. So once this x and y is getting calculated, afterwards we will apply concept of normal projectile and we will find whatever the value of u is required. So this is the entire scheme of problem solving. Now the point is, how should we do it? So the entire height h is 4r and this particular height is from here to here, it's r by 2. So this particular height is r by 2. Entire height given is 4r. So the y which we are talking about is h minus r by 2. that is 4r minus r by 2, that is 7r by 2. So this is 7r by 2. Now the velocity vector again I am redrawing over here. Now the point is, let's take it as a horizontal projectile, that is particle start with this particular velocity u, which is to be calculated. After going down a height which is equal to 7r by 2, it has covered a distance let's say x in horizontal, but the velocity with which it is striking this surface must have component in such a way that its velocity is passing through center of the dome. So when I say center of the dome, we already have calculated this particular angle 60 degree. So this particular angle is 60 degree. Velocity along x will not change, so let it be u. Velocity along y. So after falling down a height of 7r by 2, this velocity along y will become under root 2 into g into h, which is 7r by 2. So this 2 will get cancelled. Vy is under root 7gr. Now in this vector diagram, since Vy is under root 7gr, tan 60 degree, we can write it as tan theta p by b. So this is u upon Vy. So the u which is required to be calculated is Vy into tan 60 degree. Tan 60 is nothing but root 3 and Vy we already have calculated under root 7gr. So this is 7gr into tan 60, which is root 3. So multiplying these two, our answer will become under root 21gr. This is our answer. Now, as far as this particular question is concerned, I would rate it this question as one of the simplest question. The only thing is, in general, while practicing more and more problem, most of the projectile motion we usually deal with x component of velocity, y component of velocity, time of flight, range and all. So in this regard, I found this particular question a bit unconventional. As far as concept is concerned, if a particle is retracing its path, so like optics in class 9th, 10th, which you might have read, for any path to retrace, light ray must fall normal to it. So with the same analogy, if the ball is falling normal to the dome, then only it will retrace its path after collision. So its velocity vector must pass through center of the dome, and that particular line is nothing but normal to the surface. So this is the question. We will meet tomorrow again with a new question. That's all. Thank you.